Your first chapter is sets and functions. Okay, so ரொம்ப easy chapter. தெரிய வேண்டியது couple of definitions first. Set, basically set எதுக்கு இருக்கு? ஒரு collection of objects இருக்கு அப்படின்னா அது மொத்தமா எப்படி ரெப்ரசன்ட் பண்றது, எப்படி அதை குறிக்கிறது. So as a collection, how do you represent any set of objects? அதுக்கு தான் mathematically you have something called a set theory, and this is a part of that. So let's start by defining a couple of terms. So set, what is a set? So set is a collection of well-defined objects. Okay, so here this well-defined, this word is very very important. Why அப்படினா, let's say நம்ம வந்து ஒரு, so as you can see, a set is collection of all objects. Okay, ஒரு 10 object இருக்குன்னா அதை மொத்தமா சேர்த்து we can call it a set, but it should be well defined is what the definition says. So well defined அப்படிங்கிறது என்ன? Let's say ஒரு, let's take a set of all tall people in Bangalore. So tall people அப்படிங்கிறது is not well defined because being tall is something relative. ரெண்டு பேர் இருக்காங்க, மூணு பேர் இருக்காங்க அப்படின்னா இப்போ ரெண்டு பேர்ல ஒருத்தர் might be taller than the other, but that could be someone else who is taller than the person who is taller among the two, right? So that is not the correct way of defining a set. On the other hand, let us say we take a set of all even numbers between 1 and 9. So even numbers between 1 and 9 another. Even numbers between 1 and 9. Let's say this is set A and the notation ek nama pogum. Even numbers between 1 and 9, 2, 4, 6 and 8. So you know this. So set of all even numbers between 1 and 9 அப்படின்னா even numbers என்னது நமக்கு தெரியும், and you also know the even numbers between 1 and 9. So the set is well defined. You have only these many elements in the set. So okay, fine. Now let's move on to the notation. In the A equal to open brackets அப்படின்னு போடுறோம் இல்லையா? So what does this mean? So generally to denote a set we use capital letters. Okay, let's say A, B, X, C, D, P, whatever. Okay, but we generally use capital letters, and the elements in a set one the small letters use for. Of course all this does not matter much. This is just a general notation that we use. And to say, let's say this X is an element of A அப்படின்னு சொல்றதுக்கு this X is an element of set A அப்படின்னு யூஸ் பண்ணுவோம். So this means is an element of. Okay, so this symbol in the E மாதிரி எழுதுனா it means is an element of. Okay, so next let's move on to what is called a cardinality. So here in this set A, how many elements are there? You have 1, you have 2, you have 3, and you have 4. So this is a set that has 4 elements in it, and now 4 is called the cardinality of this set. So generally, how do you define cardinality? It is the number of elements in a set. So cardinality of a set is a number of elements in a set, and what is the notation used? N of A. So inga N of A another, in this case N of A is 4. Okay, so if you take some other set, let's say or a set B which has elements 1, 3, 7, 9, 13, etc. So n of b n of b will be, you have 1, you have 2, 3, 4, 5 elements. So n of b will be 5. Okay, so that is your cardinality. Next, finite set. Now we saw that set A has had 4 elements and set B had 5 elements. So here these two numbers, this 5 and this 4, these two are countable. You know there are only 4 elements and you know there are only 5 elements in this set. So such sets are called finite sets. That is, sets that have a finite number of elements in them. Okay, so it should be well defined. Let us say ipo set of all, in our example, just to see another example, set of all prime numbers between 1 and 100. So this is a well defined set and is a finite set because there are only 25 prime numbers between 1 and 100. You know that. Okay, so it is countable. All that's fine. So next, what is an infinite set? Infinite set is another, obviously, a set that has infinite number of elements. You cannot stop counting. You go on and on and on and on. Let's say on the number set of, let us take the previous example and just try to change it to accommodate into this. Set of all prime numbers. Okay. So what do you know about this? Set of all prime numbers. What is the bound? Obviously, prime numbers we start with 2. Okay. So first of all, remember 1 is not a prime number. It is neither prime nor composite. Okay. So we start with 2 and 2 is the only even prime. So we start with 2 as the first prime number. We go on 3, 5, 7, 11, 13, 17, 19, 23. Okay. But where do we stop? We don't know. Right? So this is an infinite set. Set of all prime numbers. Similarly, set of all even numbers. Now even numbers start with 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. You don't know. Right? So the bound is not defined. So this is an infinite set. Okay. Now understand the difference here. This, you can't call this a set that is not well defined. Okay, because this is well defined, you know what even numbers are. You just don't know where to stop counting. Okay, and that is why you have a different naming for these kinds of sets, and that's called an infinite set. Okay, and how do you represent the cardinality of such a set? Let's say I is an infinite set, so n of I will be equal to infinity. Okay, fine. So next, empty set. So empty set or null set. This is another, a null set is another name for empty set. Okay, so so in the finite set la finite number of elements irukku, infinite set la infinite number of elements irukku, empty set la you have 0 elements. Okay, you don't have elements at all. But again, that is a finite set, right? Because you have 0 elements. That is again a finite set. You don't have uncountable number of elements. Okay, so empty set, adukku or example eduthupoma. First of all, it is denoted using this symbol. Okay, this is a null set. Null set. So what is an example? Let us say a set of negative integers. Set of negative integers. Or let's say, oh yeah, okay, let us say negative integers that are squares. Okay, set of negative integers that are squares of let's say integers. Okay, now this example is a bit confusing in terms of the wordings, but anyway, I'll try to explain it. Okay, so set of negative integers that are squares of integers. So what do you know about this word? What are integers? Integers are all numbers from minus infinity to 1, 2, 3 dot up to plus infinity, all whole numbers. Okay, minus 3.1 etc. So it should be minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. Similarly, on the negative side, minus 4, minus 5, minus 5, so on, up to minus infinity, and on the positive side, up to plus infinity. So, in a set, squares of these integers. Okay, so when you square each of them, what do you get? So, 0 square panna, what do you get? You get 0. 1 a square panna, you get 1. 2 a square panna, you get 4. 3 a square panna, you get 9. Now, all these are positive numbers. Now, what do you get when you square minus 1? Again, you get plus 1. When you square minus 2, you get plus 4. When you square minus 3, you get plus 9. And so on and so forth. Minus 4 square panna plus 16 varum. Minus 5 square panna plus 25 varum. So, in any case, or a negative integer square pannalum seri, or a positive integer square pannalum seri, 0 square pannalum seri, you are not going to get a negative integer. Right? By the way, 0 is not a positive integer, it is neither a negative integer. Okay, so you are not going to get a negative integer. So this set has no values, no entries in it, no elements in it. Okay, so this set is an empty set. Fine. So now subset to our example pop up. Let's take two sets. Let us take A is equal to 1, 3, 5, 7, 9, 11. Okay. Let us take B is equal to 5 and 7. Now what do you see? 5, 7 in the rendu elements A layum irukku. Right? So all elements in set B are a part of set A. Correct? So B is a subset of A, and this is how you denote a subset. B is a subset of A. So B, the elements of B are all in set A. Okay, that is what this means. Fine. So this is the basic of sets and functions. Let's move on to something called equivalence. Okay, equivalence of sets. Equal sets. Okay, so idhukku vandu textbook la irukra or example eduthukkom. Let's take two sets. Okay, A is equal to x, where x square minus, I'll explain what this notation means. Okay, and B is equal to 3 comma minus 2. Now what does this mean? It just means A is a set of all x. A is a set of all x. If you draw a line like this, it means whatever comes after this line is a condition that x should satisfy. Okay, so A is a set of all x where x satisfies this condition. Okay, what is the condition? X square minus x minus 6 is equal to 0. So x square minus x minus 6 equal to 0. What is this? First of all, this has the second power, right, over the variable x, and this you call a quadratic equation. So quadratic equation has how many solutions to it? It has 2, and those 2 are called the roots of the quadratic equation. So totally this set will have 2 solutions, 2 roots. Okay, there is 2 elements to it. provided this is not a perfect square. Okay, if it is a perfect square, it is going to be the same element repeated twice. Anyway, so this, how do you solve a quadratic equation? Now, you know that. So you take minus 6, you draw a tree. So you have a coefficient of x here which is minus 1. Minus in general apota, it means minus 1, right? So you should have two numbers here such that when you add them up, you should get minus 1. So what are those? And also when you multiply them, you should get minus 6. So what are those numbers? You have minus 3 and plus 2. Correct? So x minus 3, x plus 2 equal to 0. So x is equal to 3 or minus 2. Okay. So set A redefine pannona. What do you have? You have 3 comma minus 2. So what do you see here? You have the same, exactly the same elements in set A and set B. You have 3 here, you have 3 here, you have minus 2 here, you have minus 2 here. So A and B are equal sets. Okay. Now let's take some other set C where you have C is equal to A comma B. This is the set in which set C. Now what do you observe? N of A is equal to N of C. N is another number of elements in A. How many elements do you have in A? You have 2 elements, right? And in C you have 2 elements again. So N of A is equal to N of C. But A is not equal to C, right? A is not equal to C. Why? Because the elements in A and B are different. Inga 3 in irukku, A in irukku, minus 2 in irukku, B in irukku. Okay. So A and C are not equal sets, but A and C are equivalent sets. Okay. So equal sets definition another. Equal sets, exactly same elements. Okay. So equal sets have exactly same elements, whereas equivalent sets have exactly same number of elements. Okay, their cardinalities are same. Okay, they have exactly same number of elements, whereas equal sets have exactly the same elements. Fine. Now this is the case with B as well. Okay, now B is not equal to C, but B is equivalent to C. Okay, and once again here, in the set la vandu A is equal to minus 2 comma 3 appdin ezhudindalum A is equal to B. Okay, the order in which you write the elements does not matter. Okay, understand that. So you are done with equal sets, you are done with equivalent sets. Next, there is something else. What is that? Power set. Okay, power set another. So let's take for example a set A that is equal to, let's say, A, B, C. Okay. Now, how many subsets can you make out of these 3 elements out of this set A? Let us say, first on the null set. Okay. Empty set. Empty set is also a subset of this set A. Okay. Then A mattum irukkiradhu or set. Okay, always set, you have to enclose between these two curly braces. Okay, then B is also a set. B mattum irukkiradhu. C mattum irukkiradhu is also a set. Then A comma B irukkiradhu or set. Then B comma C irukkiradhu or set. Then C comma A irukkiradhu or set. Okay, then finally ellame irukkiradhu again is a subset. A set is a subset of itself. Okay. Hope you understand that. Now all the elements of this set are a part of itself. Correct. So set A is a subset of set A of itself. Okay. So now this you have defined. All these are the subsets of set A. Correct. Now such a set you call a power set. So that you denote using this. This is the power set of set A. So basically what does a power set mean? It is a set of all subsets. Power set is a set of all subsets. Okay. Now so எவ்வளவு subset இருக்கணும் அப்படின்றது எப்படி கண்டுபிடிக்கிறது? You have, what is the cardinality of this now? N of A is 3, right? Now how many elements do you have in P of A? 1, 2, 3, 4, 5, 6, 7, 8. So N of P of A another 8. Now let's take one more set, say B, which has say 1 and 2. Okay. Similarly, let us define the power set of this set B. Obviously you start with the null set, then you have 1, then you have 2, and then you have a set that has both the elements 1 and 2. So here N of B has 2 elements. N of P of B has how many elements? 1, 2, 3 and 4. So what do you observe? When you have 3 elements in the parent set, the set of subsets, that is the power set, has 8 elements. Okay. When you have 2 elements in the parent set, the set of subsets or the power set has 4 elements. So something has to strike you now. What is that? 8 is what? 2 cube. 4 is what? 2 square. Right? So always the number of the cardinality, okay, the cardinality of a power set, let's say set X, will be equal to 2 power m if the cardinality of set X is m. Okay. And there you go with power sets. So in our next session we'll look at properties and couple of other things related to sets. We'll look at Venn diagram as well. Okay.